For more problems and videos like this for linear algebra, you can take a look at Survey Studies. Link is in the description box below. Welcome to this video. We're going to be talking about cofactor expansion in linear algebra, and the goal of cofactor expansion is to help you find the determinant of a matrix. And the first thing you want to do is always choose a row or a column that has the most zeros. So here I look and I see that this column has a 0, and I'm going to choose this column. I could have also chosen this row because it does have a 0, but it has like -2 and -3, and if I can help it, I prefer lesser numbers. And so if I have to choose between 1 and -1 and -2 and -3, I'm going to choose the 1 because it just saves you time, and you'll see when we get to it. So what I'm going to do is I'm going to make a copy of this matrix because I see 3 numbers in this column. I'm going to make 3 copies. Now what you want to do is you want to circle the first number. It doesn't matter what number you actually circle first because you're going to go through all of them anyway, but I always start with the first one. Now that number tells you, hey, we're going to cross out everything in that number's row and in that number's column. And then what's left is going to be this submatrix. And so the determinant of this matrix right here is going to be equal to the determinant of this submatrix that was formed. And then whatever number you chose, because we chose 1, we put that right here. If this is a 3 by 3 matrix, then you're going to have plus, minus, plus, minus, plus, minus, plus, minus, plus. You're going to have a matrix of plus and minuses with the same dimensions, right? 3 rows and 3 columns. And the way that you start is you always start with a plus, and then it's minus, plus, minus, whatever. But then in the next row, you have to start with the opposite of what's above it. So you could be like plus, minus, plus, minus, plus, minus, same pattern here. But right here, it has to be a minus because this over here is a plus. Then you say, okay, I circled this 1. So whatever sign is over here, you're going to put that right there. So that's going to be a plus sign. Now we move on to the next number. So I'm going to just do it over here so you can see what I'm doing. I'm going to circle the next number, which is 0. I'm going to cross out its row and its column, and whatever's left is going to be my remaining matrix. So then I'll start with the actual number. We chose 0, so that's a 0. And then its sign is a minus. So I'm just literally finding where it is in this matrix over here. So that means I'm going to do a minus sign here. And then this is going to be determinant of the remaining matrix, which is 2, 3, 4, -4. So it's literally just the numbers that remain. Great, now we're done with this one. Now we move on to the next one. But again, I'm just going to do it over here. We circle the last number. That means cross out its row, cross out its column, and whatever is left is your matrix. So what number do we choose? We chose -1. And then we also have to find its respective sign. That's a positive. So we're going to have this positive over here. So remember, the coefficients are always multiplying to the determinant of these matrices. So we have times the determinant of the remaining matrix, which is 2, 3, -2, -3. That's what this is right over here. And this is it. This is the formula to find the determinant of this matrix A. So then we would actually have to go through here and find the determinant of these. And we know a formula to find the determinant of 2 by 2 matrices. We just multiply these two numbers together. So that would be -2 times -4. That is 8. And then minus the product of these two numbers. So 4 times -3, that's -12. That becomes a positive. So this becomes 20. And so then I drop this down. So that was times 1. We don't really need this plus sign over here. And then notice, because this is a 0, 0 multiplied by anything is just 0. So that is why we want to pick rows or columns with zeros, because then we just don't even have to solve for them. So this one over here is irrelevant. It's just 0. So we don't even have to calculate it. Now this one here, to get the determinant of a 2 by 2 matrix, again, you're just going to do 2 times -3. That's -6. And then minus the product of -2 times 3, which is again -6. These two becomes a positive. That's 0. If this is 0 times -1, that's still 0. So this is 0. This is 0. At the end of the day, our determinant of matrix A is just 1 times 20, which is 20. Before we go, notice that at the end, in the formula, we ended up with 2 by 2 matrices, and luckily for us, we do know a formula to find the determinant of those matrices. But the big question is, what if we didn't end up with those 2 by 2 matrices? What if we ended up with another dimensional matrix? What would we do then? How do we find the determinant of those? Well, we would have to do cofactor expansion again. And that I'll show you how to do in the next video, so I'll see you then.